So if you're looking to where to locate these slides in your packet, these are the last, I think, 3 or 4 slides in your packet. This is easy compared to what we've been doing. So if you remember, we've learned Hess's Law, and Hess's Law says that when you add reactions, and we did Hess's Law for delta H and delta G, that when you add reactions, you can calculate the delta H or the delta G by like multiplying. If you multiply the equation by 2, then you multiply the delta H by 2. And then remember, we added the reactions. You can flip them if you remember all that stuff that we did with Hess's Law. So the same thing can be done with K's. However, it's slightly different. Okay, so if you take a look at this reaction here, okay, this is the reaction written in the forward direction, okay? And then here, we're flipping the reaction. So if we look at the, let's get the K values. So if we look at this is the K expression for this reaction, and then this is the K expression for the reverse reaction, okay? Let's say you had the K for the forward reaction, and let's say the K is, for this reaction, is, let's say, 6. Well, let's say you calculated this and it came out to be 6. Okay? And well, if you wanted to find the K for this reaction, which is this reaction flipped, what would you do? Okay? And to find the K, instead of, remember, when we were doing Hess's Law, you reversed the sign. Okay? But if when you're finding K's, instead of reversing the sign, you take the inverse. Okay? And the inverse is taking 1 and dividing it by the Keq of the forward reaction. So here I said that, let's say I said just for purposes of like having a number, the K for this forward reaction was 6. Well, the K for the reverse reaction would be 1 over 6. So instead of making it negative, you take the inverse, which is sort of like dividing it by 1, or 1 over 6. Okay. Now, let's put everything on the screen. So if you take a look at this reaction, so here we have the K expression for this reaction, and then what we're doing here is we're doubling the reaction. Okay, so when you every coefficient is multiplied by 2. So when you double the reaction, again, let's say the K for this reaction was 6. Okay, when you double that reaction, and we were doing Hess's Law, you multiplied it by 2. But when we were dealing with K's, if you double the reaction, instead of multiplying by 2, you square it, okay, or you raise it to the coefficient by which you're multiplying by. So, like, for example, if you multiplied this reaction by 3, instead of squaring 6, you would you would raise 6 to the 3rd power. Okay. Now, one thing that you need to remember, okay, if you remember your exponent rules, if you have this reaction, okay, you raising it to the half power, okay, and raising it to the half power is taking the square root. Okay, so just to let me summarize again, here, right, let's say the Keq for this reaction was 6, okay, and then what we did is we doubled the reaction. So when we double the reaction, we take the Keq of this reaction, which is 6, and then we're going to square it. So the Keq for this reaction then would be 36. So here we're getting back to like the Hess's Law thing, when we have to sort of flip or manipulate these reactions here so that we can get this reaction. So if we take a look at this reaction, okay, we need to flip this reaction, right? Because A is on the reaction that we want. A is on the reactant side, and here A is on the product side. So the first thing we know that we have to do is we have to flip this reaction. Oh, God. Keep. Sorry, guys. So, annoying. Alright, so we have to flip this reaction. And then if we take a look at this reaction, we need 2 D's on this side. So we're going to multiply this reaction by 2. So times 2. Okay, now, so we flip this reaction, right? So if you remember, when you flip the reaction, you take the inverse. Okay, so that's 1 divided by 0.5. Okay, now we multiply this reaction by 2. Okay, but when you're dealing with K's, instead of multiplying the K by 2, you take the K and raise it to the power that you multiplied the reaction by. Okay, now, it says down here, when using Hess's Law, the reactions are added, so we would add these 2 reactions. Okay, remember when we added the delta H's, but when it's K's, you're going to multiply them. So this should be a multiplication sign. So if you did 1 divided by 0.5, 1 divided by 0.5 is 2, times 3 squared, which is 9. And then you multiply those together, you get, as I'm writing with the cursor, as opposed to the pen, 18. So again, the key is here that when you add reactions and you're finding Ks, okay, instead of adding the two values, you multiply them. Only when finding Ks. If you were finding delta H, you would still add them. Okay. The first 3 questions in the homework are using these rules. So you'll need to use these rules for the first 3 questions on the homework. Have a good night.